like?
Yeah.
Are you ready to have a little glow party?
Yeah.
Yeah. We need to learn a little bit about why things glow, and then maybe at the end of our session we'll have a little glow.
Wait, are we?
So, we are we what? I'm going to let you finish that.
Are we recording things here?
You know what? You might think that we're going to record with these discs on our table, but no, we're going to do something totally different with those. Are you ready to find out?
Yeah.
All right. Remember how I said you're going to have to be patient?
Yeah, I really want to be a scientist when I grow up.
Well, that is awesome. I'm excited for you. That makes me so happy. All right, so this is Miss Kelsey over here. She's behind the camera. She's just recording me because we're doing a lot of programs these days, and we're trying to record them and get them documented in our own personal archives at the museum. And that way, when we have new educators come in, they can learn a little bit about what we're doing. And this is a very, very easy tool to teach with. So that's what that's being used for. So just pay no attention to the camera. You can wave at Kelsey from time to time. She's very friendly. So again, my name is Peggy, and I'm so glad you guys are here. We're going to learn a little bit about why things are lit up and they're glowing, because we have lots of things glowing all over our planet. Now, right now, I'm going to now take us into a whole new zone. Are you ready?
Yeah.
All right. Actually, if you close your eyes, close your eyes. When you open them, the room may look very different. You ready? Open your eyes. Oh! Well, where did everybody go? I see your white paper on the table. Wow. Oh my goodness, and these things are glowing up on the wall. And look, we have a little disco light. Oh, I bet you didn't know that was in here.
My jackets are glowing!
Wait a minute. I need to find everybody. Hold on. There you are. Oh, man. Okay. Well, now you got a little bit of a taste of how we're going to spend some of our time in this room. Now, you'll find on your tray a flashlight. Now, how many of you love to play with flashlights? I love playing with flashlights. So, we're talking about light. Now, everybody put your hands down. I'll give you a chance to ask some questions in a little while, okay? But let's just learn a little bit about what this light means and what it does. Now, light is energy. Did you know that?
Yeah.
Now, we know we have a lot of energy all the time. We're moving around and you've probably been told, you need to calm down, chill out, you got so much energy. But sometimes we just have this energy that we want to burn. Well, we have energy all around us. And that's partly why we have energy. We have energy in our world. We get energy from the sun. We get energy from other types of things in our planet. But light is probably one of our favorite kinds of energy because we need it in order to see each other, right? Now, we're going to have a little test. I want everybody to grab your flashlight, and you're going to learn how to turn it on and off. Now, there's a little button on the bottom, and I want you to point it straight up to the ceiling because you don't want to point it in your eyes, and you're going to turn it on and turn it off again. And turn it on. And turn it off. Very good. Oh, you passed the first test. Excellent. Now, I want you to look up and see if you see any colors. Do you see any colors?
Blue.
You see blue? You see gray? What about
gray?
What about on the walls? Do you see some colors on the walls?
Gray.
Okay, so the reason we can see colors is because there's light in the room, and that light is reflecting off of all the surfaces. And that light that we see looks like it's white, just like this flashlight, but it's made up of all the colors of the rainbow. And because of that, all those colors have different kinds of energy, different waves of energy. Can everybody give me a wave? Ooh, yeah, all right. So these waves of energy are all bouncing everywhere in this room. And we get to see these colors because of that light bouncing off of the surfaces. Now, you see colors, but I'm going to turn the lights out, and then I want you to look and see if you can see any colors when I turn the lights out. Okay, you ready?
Close your eyes.
Here we go. Do you see any colors? Don't turn on your flashlight yet. Oh my goodness. You're excited. Now look at the wall. Does it look dark?
Yeah.
flashlights and shine it on the wall. Now do you see color?
Yes.
Wow. So light is very important to all of us to be able to see different colors and to use that energy to find all those different colors. Now, that seems like a crazy idea. You're thinking that's a white light, of course, it's shining on this gray surface, and that's what I see. But light is energy. That energy is moving to that surface, and it's bouncing off of the surface or being absorbed in the surface, or maybe even going through a surface. It just depends on what surface we have. Now, turn the lights back on. So, that was your first test to make sure we could find colors with our lights. So we did, we found some colors. Now we're gonna do another test, okay? And I'm gonna show you this one up here. Do you think this black piece of paper will let me put the light right through it?
No.
Well, let's test it out, okay? I'm gonna turn the lights out. So, you don't even see it. You see it now?
Yeah.
Good, now,
No.
can you see it back here?
No.
All right, so you turn your flashlights off. So you don't see any light coming through it. So this black paper is the darkest color. It's really kind of all the colors combined. And it's absorbing, or it's actually allowing all this light to just get right there on that black surface and bounce off of it, okay? It's not letting any light pass through because it's rich in all the colors. We call that opaque. Can you say that word?
Okay.
Excellent job. All right, so that was our first test. Well, let's do another test. This one is this really cool, kind of ghost-looking. Ooh, do I look like a ghost? Ooh. All right, no, I'm not a ghost. Okay. I'm a real person. All right, look at that. Now, do you see it? What color does that look like?
White.
Now, can you see the light when I put it through?
Yes.
Ah, well, we call that translucent. Can you say that word?
Translucent.
Oh, that's such a big word. Let's say it again.
Translucent.
That means some of the light is bouncing off of it, but some of the light is getting through. Because you can still see the flashlight, right?
Yeah.
So that's very different from that black paper that's opaque. Now, let's try one more thing. This is a cup. Can you see the light? Can you see all the light? Pretty much. The flashlight kind of looks like it's the same, right? So that cup is clear, and we call that transparent. Can you say that word?
Transparent.
Oh my gosh, we've learned 3 vocabulary words here in just a short minute. Opaque is not letting the light through. Translucent, a little bit of light through and some of it bouncing. But transparent means it's going all the way through the surface. So that's real important when we work with light, to understand what light will do. Now, I have another fun little trick for you. Did you notice that these sheets are glowing over here? Did you notice that? All right, so I have this piece of material. Now I'm going to shine the light on this and watch what happens. Whoa! You still see where the light was?
Yes.
Oh my goodness. Look at that. So that means the surface is very different from all the other ones. This surface is what we call phosphorescent. Say that word.
Phosphorescent.
Wow, you guys are getting so smart. It's amazing. Your vocabulary's expanded so much. I'm taking the light and I'm just putting it straight on here. Now this is white, what we call white light, or we call it visible light, right? And that light is being absorbed. It's just being absorbed in the material, and then you're slowly seeing all the energy coming back at you. That's pretty cool, isn't it? Now, all of these experiments I just did is with what, ooh, adjustment please, everybody adjust. All right, so we call this visible light. It's on the light spectrum, and it's made up of all the colors in the rainbow. Can someone tell me all the colors of the rainbow, possibly in order? You want to go for it?
It's purple, orange, and red, and all different colors.
All different colors.
Red, blue, yellow, and red. Oh, I got it.
You got it?
Red, orange,
would that be a rainbow?
No.
No. Well, we're going to test out that idea because now I have something really fun to show you. And that is, I got to get one. Oh, there's an extra one right here. I forgot. There's an invisible person. They don't mind if I borrow this. You were wondering what we're doing with this disc, right?
Yeah.
You thought we were going to cut a record today.
Oh.
No, not going to do that. This disc has lots of grooves in it, lots of lines in it. So now, when I flash a light on here, I'm going to create what we call a prism. Have you heard of that word, prism?
Prism.
That's when you take light and you bend it in all different directions. And that energy, that white light energy, breaks up into all the colors of the rainbow. Let's test it out and see if I'm correct, all right? So I'm going to take my flashlight and I'm going to shine it on my disc. Let me find a place. Hold on. I'm just going to use this. I'm going to let you be a helper.
All right.
Can you hold this for me? Of course. Thank you. All right, so I'm just going to shine it on here. Got a very dim light. Do you see any colors?
No.
You see some colors? I'm playing with it.
No.
Now I'm playing with it. Oh, look, and now I see some blue. You see some blue?
Yes.
Now here's what I want you to do. I showed you my experiment with it. I want you to put your disc on your tray and put your white paper right by your disc. And I want you to shine your light on. This is the side that you're going to work with. This side, not the side that's got Office Depot on it, but the other side. And I want you to shine it on the paper and see if you can see all those colors in the rainbow.
See, I can already see it. Mama,
Do you see it? And if you find your rainbow, see what color is on
a rainbow. I'm putting it at an angle, then I'm making it into an onion shape, and then it makes a rainbow. Watch up there.
You want me to watch it there?
You are breaking up all the energy in that light to make it all the pretty colors in the rainbow. Alrighty, I'm about ready to turn the lights back on, but I hope you all found some colors from your lights.
Turn your light off on your tray.
Okay, so you can turn your flashlight off and that way we'll save the battery. That is really a cool experiment. And what we're learning is when that white light hits all those little grooves, it takes that light and it bends the light based on the energy that is hitting the groove. Now that's like very, very difficult to understand. My brain is hurting a little bit from all that information, but I'm gonna break it down. You ready to break it down?
No.
All right, red. Let's talk about the color red. Do we like red?
Yes!
I'm a big fan of red, yes. Red is the master of light energy because those red light waves are big. Everybody give me a big red light wave. They're big and they're kind of wide and slow. Now if you did this, could you do this for a long time? Everybody do this. Could you do this for a long time?
No.
I'm not getting really very tired.
My energy is, I run out of energy.
You're running out of energy? Well, that red. Really?
Even if I screw up.
Well, calm down. You don't want to run out of energy. So that red energy or wave, it's so big and so wide, it can travel a long ways. And so red energy moves all the way in one direction. And that's why we see red on the top of our rainbow. That's pretty awesome, isn't it? Now, when you go down, is green sort of in the middle?
Yeah.
All right, so now that green energy light wave, it moves a little bit shorter. So we go a little shorter, and a little faster. It takes a little more energy, doesn't it? Well, you're a chicken winger. I like that. Waving. Now that green energy, it's coming to that little disc, and instead of going all the way over with the red, it's moving differently, so it's kind of going into the middle, right? Now we're going to be the one color that's on the bottom. What is that color?
Violet.
Oh, what's kind of in that tone of violet?
Purple.
Blue. It's blue and purple, right? Blue. So that blue light wave, is it the opposite of the red one?
Yes.
Kind of. It's kind of moving a lot different from the red one because it's going in the other direction. So now that blue light wave, let's go really short and really fast. Ready? I'm so tired. I'm not going to do that. That blue light wave has to work a little harder and it's moving a little faster. So that is a great way to see all the different energies that we get from light by looking at that spectrum. It's pretty awesome. Now we're going to do another activity that I just love so much because I'm a big star fan. Do you love stars?
Yeah.
I love stars. Now I have given you a little sheet that you can use if you'd like. This is an option. These are constellations. How many of you look up in the sky at night and try to find the Big Dipper?
Me? No, I try to find the Little Dipper.
You find the Little Dipper? All right, so, but believe it or not, when you see all those other stars, they are constellations. Now you have at your table this little styrofoam bowl, and you're going to each take one, okay? So you're each going to get a bowl, and you're going to turn it upside down. Now, here's the important part.
You want me to do one?
You can look at your constellations or you can make up your own. We're going to create some stars and we're going to kind of learn about how light can create little stars or little pinpoints of light with using shadows, okay? So we're going to learn about shadows right now. So we're going to use one of these little skewers, and there's a pointy end on these skewers. Be careful. If you don't, and be careful. Now, you're going to just put a hole right through your styrofoam, and you're going to push it all the way through to make it big enough, and then pull it right back. And you're going to try to create your own constellation, okay? If you don't want to do a constellation, you can make a star or a smiley face or an initial of your name. But you're just going to make some noise and cut some holes. Styrofoam. You can make a shadow, okay?
Put it space between.
All right, so I'm about to turn out the lights, so be careful with your skewers. Please put them down if you are a little uncertain. Here we go. All righty, so now you're going to take your flashlight and you're going to shine it through. This is where there's one more element to this whole thing that you're going to learn about. If you shine it on the ceiling, it may look a little unfocused. Does it look a little blurry? You see a little blur? Oh, I see. So if you want to try to focus it real close up, put it on your paper. So this is a fun activity you can do at home. This is kind of fun. You can do in your bedroom with a board. You can get a flashlight and get something and make little holes in it and shine it up on your ceiling, and you've got your own constellations. You've got your own star show. Now, something to remember is if you move the light back away from it, it might look a little different than if you have it real close up. Because those light waves are moving at angles, and there might be one point where it focuses really well, and the rest of the time it might be a little too spread apart or not quite focused. So that's what we call our focal point. You can find your focal point by shining at different distances. Now if you want, I suggest you name your constellation. You can name it after yourself.
Big Dipper. That is so different.
Okay, guys, stop and listen.
Keep your constellation, and you can take it home if you like and play with it at home. That's up to you. Or you can leave it here. Now what I'd like to have happen is the adults at the table can collect the trays and just put them off to the side. You can bring them actually over here onto the tables. But I want the students to keep the flashlights. You can put them in the flashlight holder there. Okay. All right. So now we all have the room. Have you noticed the purple light in the room?
Yeah.
All right, so this light,
Ribbit.
you see my flashlight? You see that blue light? So that light is actually, it has a name. It's not white light, or what we call visible light. It's called ultraviolet light, or UV light. Say that.
UV light.
And it stands for ultraviolet. Now this is also on the light spectrum. But this light moves a little bit slower than our white light. This ultraviolet light is energy just like the white light, but it moves a little bit slower. And now we're going to see what happens when I put that ultraviolet light on this board. And watch.
Whoa. It moves a little bit brighter.
It really glows, doesn't it? Because it's actually absorbing all that energy and it's slowly emitting it back at you, very slowly. That's really fun. Now, there are things in our world that love ultraviolet light. And phosphorescent sheets is one of them, this phosphorescent. But this is just looks like a bottle of water, right? But this is tonic water. And look, it kind of glows. You see the glowing light? The light is very
Tonic water.
See if I can
Tonic
find it.
water. Wow.
My ultraviolet lights are a little weak. Weak at the knees. Here we go. Oh, that's better.
Oh,
All right,
that's
you see how it's glowing? Wow. Now, this is a natural ingredient called quinine. Say that for me.
quinine.
And that exists in what we call tonic water, and it exists in other things as well. Now, there's lots of natural ways for things to glow. In the ocean, there's actually algae that sits on top of the ocean, and when the waves hit it, it gets activated, and it illuminates just like this. That's pretty cool. There's videos of that, and that's pretty awesome. They have places in Florida that are like that. So this is taking in the ultraviolet energy, and it's just emitting it very slowly and glowing back at you. And that's how those little glow things work when you put stickers up on your wall and they glow in the dark. That's what it's doing. It's absorbing the light. So I'm going to give you your own sheet to play with. You're going to find at your table, there's a couple different options. You have these there's a couple of these at your table that you could turn on. They're like a little pinpoint. Adults, you can help turn these on. They do snap on. There's a little switch on there. And they click into place. Simple. Or you can pinch it. You can pinch it like this. This one is not clicking for me, but some of them do click all the way on. I'm going to give each student a sheet that they can play with. And we have stencils, and we have little animals, and you can put them on the sheets and make shadows and play with the ultraviolet light. Now, you can also use the white light. You don't have to use the ultraviolet light. So you can use your flashlight to do it too. You have an option. And now you get to create your own world.
She said they can use their flashlights too, not just the black light.
Great job.
Hey, pick up your hand.
Oh!
Here, here's your flashlight.
Whoa! Got three, look. We got three.
Here, take your
How are you gonna erase
flashlight.
it? Oh! The sun! I like the happy sun!
Here's a UV light if you want to use this.
Do you want to try this?